So as part of assignment 4, advanced, what we need to do is in the convolutional neural network, which we are doing it for MNIST dataset, uh, the number of channels at each layer uh, can be given as a variable parameter which can be changed from the interface, from the UI. And at each layer, what would be the um, and also to select which optimizer we are using, Adam versus SGD. Um, once and there will be two different models, basically having different output channels of each layer. Um, the number of layers are fixed, but the value for output channels can be varied, and then the compare um, of the two models are done. The result of its accuracy and losses are shown in the form of graph. Additionally, I have added the output mm, of the image also after every layer. What kind, like first layer generally detects the edges, and the second layer uh, more like shapes, and then the abstraction layer, etc. So I'll just I have created a using cursor. I created the front end in React and the back end and FastAPI. I'll just execute both the front and back end. I've used UV as Python environment manager. So I'll just first activate the okay. So basically in the back end there will be Python environment. Once it is a Python environment is activated, um, I'll run I'll run UVCon. So UVCon is running on the port 8000. Then I'll run the front end by npm start. So now the back end and the front end is running. There is two model. I'll change the epoch to 3, and that's epoch to 3. Um, Now here the output of each layer, output channel will reduce change as a comparison. Like let's say we'll make 16, then 32, and 64 in Adam optimizer, and 32, 64, 120 in SCD. I'll do a comparison. Basically, the model is running. The training is happening. It is the epoch 1. It is actually the model architecture, which is generated by Torch Wiz. It talks about different weights and biases at different layer, and how the um, different channels and um, channels are calculated. I've also done a layer visualization, which will be like the model 1 layer visualization. Then in different at different layers, what we can actually see. So generally, in the first layer, it will be edges. If we look at, we can zoom the image and see. Um, in the second layer, it's more like shapes evolving, and the third layer is more like an objects, and then there will be a fully connected layer, and then the output. Uh, I've used dropout max pooling as well as to reduce dimensionality. This is the comparison of two different model. We can clearly see that model 2 is better. If you look at the ISCON channel, it is 2 is relatively better. We can see that model 1 and model 2 there is no result. If I look at it, and yes, okay, it is still running. So once it completes, optimizer, yeah, so we can see that the model 1 is completed. 3 epoch, I have given the 3 epoch for model 1. So it is once the 3 epochs are completed, it is showing that how the model accuracy is increasing, and there is reduction in loss. There is still model 2 is running for epoch 3. If we look at it is in the epoch 1 as of now. So yeah, we can just see the result in terms of the visualization as well. If we look at the different activation, which is ReLU, and optimizer is Adam and SGD for different this. I can see here that the second epoch is also over and third epoch is running. After finishing third epoch, it will give the comparison between the two models in terms of accuracy and loss. So this is the second epoch is running basically for all the batch size of 100, and this is the second epoch. So when the third epoch gets over, it will also show the model 2 details as well.